Now, if you watched my previous video in this series, you'll know that we talked about what a log was in a given base. Let's say a. The log of a number in base a was equal to x, implied that a to the power x equaled that number n. Or you could use the reverse of this. And from this rule, I showed you that the log of any number in its own base, say a in base a, was 1 because that base a raised to the power 1 equaled the number a. Okay? And then also the log of 1 in any base, let's say a is always 0, since that base a raised to the power 0 equals the number 1. Now what I want to do in this video though is extend our knowledge of logs to basic rules that we're going to be using. Rules which we'll use in simplifying expressions and also in equations. And the first rule I want to introduce you to is this one here, called the multiplication rule. It can be shown that the log of x times y in base a is exactly the same as the log of x in base a plus the log of y in base a. Now I'm giving you this and other rules without any proof. The proofs of these are in the next video in this series. Now this can easily be demonstrated on any scientific calculator. Let's say we take the log in say base 7 of say 30. So what do we get? 1.747, etc. Now 30 is exactly the same as say 5 times 6. So I could just verify this by doing the log in base 7 of 5. And if we move the cursor across, plus, and then if I take the log in base 7 of 6, press equals, we get exactly the same value. So do try experimenting with this rule on your calculator just to verify that it's true. Now there are other rules. I'll introduce you to 2 more rules. The next rule is the division rule. The log of x divided by y in base a is exactly the same as the log of x in base a minus the log of y in base a. And you could verify this rule easily on your calculator, just as we did with this one up here, the multiplication rule. Another rule is this one. It's called the power rule. The log of x to the power n in base a is exactly the same as n times the log of x in base a. And again, maybe you might like to try and verify that one on your calculator. Now, I've got a short exercise here, 4 questions which I'd strongly encourage you to have a go at. They look at the ideas that we've just been discussing here and in the previous video. The first 3 questions ask you to simplify these expressions. And when it comes to number 4, just want you to expand this expression. Okay, so give you a moment just to pause the video, have a go at these. When you come back, you can either fast forward just to check your answers, or I'll take you slowly through the work solutions. Okay, welcome back then if you had a go. So for this first one, the log of 4 in base 3 plus the log of 5 in base 3. Well, what's this going to be equal to? Well, we pick up on the multiplication rule here, and we should be able to see that this is the same as the log in base 3 of 4 times 5. 4 5's 20. For number 2, log of 72 in base 2 minus the log of 9 in base 2. This uses the division rule. So what we're going to have here is the log of 72 divided by 9, and this is in base 2. Now 72 divided by 9 simplifies to 8. So we've got the log of 8 in base 2. But unlike this one here, this one has got a nice clean value. because for this one we should, by this rule here, realise that you could raise 2 to the power 3 to get 8. So in other words, the answer to this is exactly 3. 2 cubed gives us that 8. Now in number 3, I picked this one because remember in the previous video I showed you that if you just got a log without a number written here, the base is assumed to be 10. And also, before you can use the multiplication rule here, we've got this 2 in front of the log. So we need to simplify this first term first of all. So what we have here is the log of 5. Remember, it's in base 10 then, and we use the power rule here to bring the 2 up as a power on the 5. So we've got the log of 5 squared in base 10 plus the log then of 4 in base 10. Well, 5 squared is 25, and now we can use the multiplication rule. We can see this as the log of 25 times 4, and this will be in base 10. So we've got the log of 100 in base 10. And this is an exact result. You have to raise 10 to the power 2 to get 100. 10 squared is 100. So the log of 100 in base 10 is 2. Now for the last one, we've got to do the reverse process. We've got to expand this expression. So this is going to be the log of x cubed, and because we're multiplying it with y squared, we can use the multiplication rule and say this is the same as plus the log of y squared. And then we're dividing by z, so we can say subtract the log of z. Now I haven't written the base here, so technically it's base 10, but whatever that base were, it would be the log in that base all the way through. Now I could use the power rule on this term and this term here. For the first term, bring the 3 out the front and we have 3 log of x. And for the second term, it's going to be plus 2 log of y. And the last term just stays as minus the log of z. Okay, well I hope that's given you some idea anyway on how to work with these rules for logs. And as I said earlier, if you want to prove these rules, then do check out the next video in this series.